Okay. Let's go ahead and do the first. Let's say I've got 3, 4, 1, 6. What I'm going to do is I'm going to switch the rows. Simply because I've got a 1 here, it would be convenient to have that 1 up here. I wouldn't have to do anything to get a 1 here. Okay. So if this is 1, row 1 and row 2, then I'm going to have row 2 here and row 1 here. I just switch them. I've got 1, 6, 3, 4. So a lot of times you can look at a matrix and see how you could rearrange the rows. Now, why can I rearrange the rows? It's because these rows could stand for, well, when we get down to here, they stand for equations. Okay, and what we're ultimately going to want to do is do this. Now, I wanted you to do this first before we complicate it with numbers over here. Although these numbers just go along with whatever we do when we reduce this matrix. This matrix being the same as this part, this matrix, steps are going to be identical when we reduce from over here. Well, if you have a bigger matrix, a 3x3 or 4x4 matrix or whatever, you look for convenient ways to rearrange the rows. Okay, and that's all I'm going to say about that right now. This is a convenient way to rearrange the rows. This gets one of our goals, which is a 1 right here. So we're going to want to leave that 1 there. We don't want to mess with it. Okay. Next thing we want to do is we want to get a 0 here. Now, if we multiply this row by 3, or let's say -3 times this row added to this row, we're going to leave this row the way it is because we like that 1 there. We're going to do -3 times the first plus the second. So write it out yourself. Just show me what you get if you multiply this first row by -3 and add it to the second. Okay, now this step, which is still getting people some trouble. First of all, circle number 2 here refers back to the second row of the previous matrix, not back to the second row of this matrix. Okay, so circle 2, with every new matrix, the circled numbers refer back to rows of the previous matrix, not to the rows that they came from on the matrix before that. Okay, so if you multiply this first row by -3, I'll do it over here. I'm going to get -3, -18. That's -3 times first row of this matrix. And then if I add this to the second row, what do I get? Show me with your fingers. What do I get in the first? I get that 0, right? And for the second one, I get negative 14. Now, I generally don't want to write all this out. I just look and say, okay, well, negative 3 times 1 is negative 3. And I add that to 3 and I get 0. Okay. So first, when I do what I say here, second row, I wrote the wrong number here, which might be part of the confusion. First row of this matrix is 1, 6. So I put a 2 there carelessly and then never thought about it again. So I apologize for that, but you can still do what I said. Unfortunately, I've written the second row here instead of the first. But the key is what happens when I add the first row, negative 3 times the first row to the second. Okay, negative 3 times the first row means I take negative 3 times every number in this row and add it to this one. And that's going to give me negative 3 plus 3. Then I take negative 3 times the second number in the first row and add it to the 4 here. That's going to be the negative 18 and the 4. So that's negative 14. So that's what this instruction says to do. My original instruction with the 2 here would have had the 3, 4 here, but we don't want that. We want a 1 here. Okay. Now, the point is that some people want to go ahead and multiply this thing by negative 1 to get a negative 1, 6, or even by a negative 3 to get a negative 3, negative 18, and write it down in the matrix. You don't want to do that because you've already got the 1 that you need. You don't want to go messing with that 1. You just think, what multiple of this do I add to this? And if you've got a 1 here, it's really easy to figure out what the multiple has to be. Okay. If there's a 1 here, I just take the negative of this number, multiply it by this row, and add it. All right. Now, the next thing that people are kind of not wanting to do, I'll have my row 1, then I'll have row 2 divided by negative 14, which gives me 1, 6, 0, 1. So I've got everything except the 0 in this position. How am I going to get a 0 here? Okay. Now, at this point, we're really home free. All we have to do, we've got a 1 here. We see that if we multiply this by negative 1 and add to this, we get the 0 that we want. And since we've got a 0 here, we don't affect this 1. So if I do this 1, about 2 there. Probably can't read it, but it's pretty obvious. 1 minus 6 times row 2. Row 1 minus 6 times row 2, okay? Means I take whatever number's here and add negative 6 times this number. That's going to leave me 1 since this number is 0. And then I do the same here. I do the 6 and then minus 6 times the number in row 2. The number in row 1 minus 6 times the number in row 2, which is going to give me 0. And then row 2 is still row 2. And we're done. Okay. Now, these same exact steps will solve this matrix. We'll reduce this matrix to this form. And then because if people have been writing out, that this is just x equals whatever this number is, y equals whatever this number is. Stands for the system of equations. X equals this number, y equals this number. And that's the solution to the system. So let's see if you can follow these steps, 1, 2, 3, 4 steps to reduce the matrix and get a solution to the system. Now, unless you want to do this the hard way, you're going to switch these two rows just like I did here. Okay. If you don't switch the two rows, you end up with even nastier fractions. Fractions aren't all that nasty, but you do end up with fractions. And as I said, you need to know how to deal with the fractions without using a calculator. Do them. But for now, I don't really care how you do them as long as you do these steps right. Okay. Fraction is going to be a big deal in for calculus, especially when you get the fractions involved in rational functions. Okay, so we have this. Now, what do? Well, first of all, you just look at this and say, well, if I subtract 3 times this from this, I'm going to get that 0 that I want right there. Okay. But of course, if you follow the steps that I outlined here, that's exactly what you're going to do. You're going to get 1, 6, 11. And then -3 times 1 is -3. You add that to 3. You get 0 following this instruction. And -3 times 6 is -18. You add that to 4, you get the -14. Then you got to do -3 times this and add it to 8. And everybody, unless you did switch the rows, have a -25 there. And maybe you did even if you did switch. Okay, so anyhow, there it is. So everybody's pretty good up to this point. Now, next 2 steps are actually straightforward. Once you have it in this form, and we call this an upper triangular form, you got this triangle here at the diagonal and above it, and a 0 down here. Everything is going to fall into place rather nicely. Next thing I want is a 1 here. I'm going to get that by dividing this row by -14. Of course, that's what the instruction here says. That's what we did over here. So I've got 1, 6, 11, and 0, 1, 25/14. I think everybody got the 25. Well, we got the negative this. And we're just ready to get this just by dividing this row by -14. Divide this by -14, I get 1. Divide this by -14, I get 25/14. Then I've got to add 6 times row 2 to row 1. It gives me 1, 6. And then it's going to be, 1, 0, 0, 1, just like it did over here. In other words, subtract 6 times this from this, I get 6 minus 6. That's 0. Then I've got to do this minus 6 times this. So I'm going to have 11 minus 6 times 25/14. And here I have 25/14. Now the question is, how are you going to calculate this? Well, if your calculator does fractions and you want to do that today, okay, but make sure you know how to get the common denominator and multiply it out. Okay, so I'll just kind of do that over here. Being real explicit in the way I do the fractions. I get the common denominator here by multiplying 11 by 14/14. And I'll write that 11 over 1 times 14 over 14, so we know where the numerators and denominators are. So we can apply the rule says you multiply the numerators and you multiply the denominators. Of course, this 1 is understood here. Maybe you know how to multiply 11 times 14 over 14. But let's make sure that, that we got that into the simplest possible form. Okay, that gives us 154 over 14 minus 150 over 14. And then that gives us 154 minus 150 over 14, which equals 4 over 14, which reduces down to 2/7. And a lot of that is slightly off the screen, which is unfortunate. But again, we'll apply the 11 by 14 over 14. We need a common denominator. Okay. And I write 11 over 1 times 14 over 14. That means 6 over 1 times 25 over 14. Since we have numerators and denominators to match up, then 11 times 14 is 154. 1 times 14 is 14. 6 times 25 is 150. 1 times 14 is 14. You got a minus there. Now that we have the same denominator, we can write 154 minus 150, all divided by 14. We've essentially used the distributive law. It's 154 minus 150 over 14. Think of that as 1/14 times 154 minus 150. You're going to get this. So this is equivalent to this. You then simplify the numerator, you get a fraction, and you simplify that fraction, you get 2/7. So this would come out one, 0, 2/7, 0, 1, 25 over 14. Meaning that's a solution, meaning that x equals 2/7, y equals 14. So as you know, this could stand for the equation 3x plus 4y equals 8, and x plus 6y equals 11. I plug 2/7 in for x, 25/14 for y. In this equation, I get 6/7, which is 12/14, and 100/14. 4 times 25/14 is 100/14. That's 112/14, and 8 goes into 112. I mean, 14 goes into 112 8 times. Okay, 8 times 14. That's 80 plus 32. 10 8s and 4 8s. Okay, 80 and 32 makes 12. That all checks out, and this one should check out as well. Okay, we get 2/7, and that's 150 over 14, which reduces down to 75/7. 6/7 and 75/7 is 81/7. Even my mental arithmetic's going haywire. There's something wrong here. Let's do it again. We get 625 is 150. And that much you get 75. That's 75/7. Okay, yeah, 2/7 and 75/7 is 77/7, and that's 11. 11 goes into 77. 7 goes into 77 11 times. Okay, so everything checks out. Now you definitely need to be able to do this for any system of two equations and two unknowns. You write it out as an augmented matrix and do the operations. The operations are simple. You can switch rows. You can multiply a row by any number you want, or you can add any multiple of a row to another row. Those are the three things. Of course, Open Math has told you that, okay? With those three operations, you can reduce any matrix. If it's reduced. Now remember, when you have two equations and two unknowns, it's possible that these equations give you parallel lines. Now, parallel lines could coincide. You could have the same parallel line. In other words, both equations could be the same. Or you could have two parallel lines that don't coincide, which means you'd have no solution. Okay? So in one, you have infinitely many solutions. In one, you have no solutions. This matrix will tell you, although we're not going to go that far into it. Okay, let's see how it works out with a 3x3 matrix. Okay. You're going to want to get a 1 in the first row. Okay. I want a 1 to be the first number in the first row. I could divide this row by 4, and I get 4, 0, 3/4. I'm going to get 1, 0, 3/4. You see that? Divide everything here by 4. I get a 1 here, and then whatever follows is what I get. Okay, so that's an easy way to get a 1. Okay, but I've got a fraction over here. Maybe I want to avoid that fraction, and maybe it doesn't make any difference. Yes, let's practice. I'm going to say, I got 2, 4, 6 here. If I divide this by 2, I get 1, 2, 3. Maybe that's going to be easier. Okay, so I'm going to switch. So I'm going to put row 2 here, row 1 here, and row 3 stays where it is. So I've got 2, 4, 6, 4, 0, 3, -7, 3, -5. Then I'm going to divide by 2 up here. Row 1 divided by 2. Give me 1, 2, 3. Then I have 4, 0, 3, -7, 3, -5. In other words, rows 2 and 3 from this matrix stay the same. Only row 1 from this matrix gets stepped. Well, now that I've got a 1 here, I can use it to get rid of the 4 and the -7, because I'm going to want zeros here. Because of course my goal is to have a 1 here with all zeros below it. So I can do row 1, which I'm never going to change until the end when I try to get rid of the 2 and 3. Let's subtract 4 times the first row from the second. Well, here's my first row. Means I just go through here, keeping in mind what I need to do. I do -4 times 1 gives me -4, add that to 4, and I get 0. And then I do -4 times 2, and add that here, and I get -8. Here I get -4 times 3 is -12. Add that to 3, I get -9. Then I can also use this one to get rid of that -7. I can do row 3 minus 7 times row 1. And I'm going to get a 0 here. And then, in other words, 7 times 1 is 7, add that to -7, I get 0. Then 7 times 2, that's 14. Add that to 3, I get 17. And 7 times 3 is 21. Add that to -5, I get -16. Okay, so to repeat, I've got 1, 2, 3, 0, -8, -9, 0, 17, -16. Now, if I had the equations written out, I could be doing the exact operations, exact same operations on the equations. It's actually easier to operate on the matrix. And usually this is going to be an augmented matrix, but I'm just demonstrating the process of reducing. There's an augmented matrix, you have another row. You know, there's one x plus 2y plus 3 equals whatever number you have here and so forth. Trying to avoid that much arithmetic just to demonstrate the process. Okay, so what am I going to do here? Well, here's what's going to start getting a little messy, but I'm going to take row 2 and divide it by -8. Why? Because I want a 1 here. I want to have 0, 1 in this row. So I've got 1, 2, 3, 0, 1. Now we start getting into fractions. 0, 1, 9/8. And then I'm also going to want a 0 here. I'm sorry. Okay. I mean, I'm going to want a 0 here. And have to do a little work to get it. So this is just the third row. Well, now, you know, I'm going to want a 0 here. I'm also going to want a 0 up here. So while I'm at it, and I'm going to do 2 operations. I'm going to do row 1 minus 2 times row 2. That's going to give me 1, 0. Now I'm going to get a fraction up here. And minus 2 times 1 is -2. I add that. Minus 2 times 9/8 is -18/8. And add that to 3, which is 24/8. And I get 6/8, which is 3/4. And I'm not going to write out that arithmetic. I might not even be correct. I did that once in my head. And then down here, of course, row 2 is not going to change at this point. But row 3, minus 17 times row 2. Okay, because I multiply this by 17 by -17 and add to this, I'm going to get 0. Now, this is going to be fun. I multiply this by 17. I get 153/8. See if I can remember that. And then -16 is 128/8. -128/8. So -153 and -128 is -281, I think. Okay. That's getting pretty ugly. And I'm not even sure I did that right. I think it might be right. Okay. All that's left is to get a 1 down here and then get rid of these. So to get a 1 down here, it's very convenient. Whatever number I get down here, when I got the 2 zeros in front of it, I'm going to multiply by its reciprocal. It's going to give me 1. So it really doesn't matter whether I calculated that right or not, at least as far as this matrix goes. Now, if you had an augmented matrix where there's another number over here, you'd have to multiply that number by -8/281. Your fractions would be getting big and you'd be forgiven for using a calculator. Okay. But at this stage, I'm going to take row 1. Well, I guess maybe that should be legible. Better. Row 1 minus 3/4 of row 3. Okay, so 3/4 is 0, 0, 3/4 is 0, 0. So you do 1 minus 0, 0 minus 0. But then you're going to have 3/4. Well, 1 minus 3/4 times 3. 3/4 times 3 gives you a 3/4, -3/4 here. Add that to 3/4 and you get 0. That should be obvious, but I have to process it more. And then in the second row, we're going to do row 2. Minus 9/8 of row 3. And down here, we're just going to have row 3. So a lot of the fraction stuff gets simplified if all you're trying to do is reduce a 3x3 matrix. If it's augmented, then the fractions get worse. Okay. Okay. So that's one thing. Yeah, that's one thing you want to know how to do, or at least, especially if you're in the pre-calculus, you're going to need to be able to do that on the exam. If you have taken pre-calculus yet, gives you a really good head start on that part of the course. Okay. And I think everybody's doing fairly well with this. Now, I hadn't planned for today. I didn't plan to spend this much time on reducing matrices, but it's all we needed to do it. This being a support course, you need that support. You might not really need it, but hopefully it makes your life easier. Hopefully it's helpful. I plan to start some review. And I hope I'll be able to do that in pre-calculus class and start some review. If not, The rest of the sport course is review, and I think the rest of the pre-calculus course is probably going to be review. So we ought to have 3 good days to get a lot of review and help you along with preparation for the exam and for calculus, and of course, for the final test. Okay. So with that, I don't have time to start a review in 3 minutes. And I usually hold you over a little bit, so I'm going to let you go 3 minutes over.